Hello everyone, so welcome to another video of this advanced Python series. So this is the third video of this series. So till so far we have discussed about what are meta classes and what are decorators, and we have seen like there are two types of things we can do to achieve meta programming in Python, right? So one is basically the decorators and one is meta classes. So in the previous video, if you have seen, so I have discussed about the decorators in Python, and in this particular video we are going to discuss about what are meta classes and how we can use meta classes. So basically we'll see the structure, how Python has used meta classes and how type has been used. So these things we'll be covering in this today's video, so stay tuned and I'll see you. So if you have not seen the previous video, the link in the I button, and in the previous video I have discussed about the Python decorators and how we can utilize these decorators, and basically the coding part I have discussed. So just refer the video in the I button, and I have uploaded the code in the GitHub also, you can refer that also. So just note this repository, okay? Just note this repository. I'll be uploading all the materials and notes here in this repository itself, okay? Fine. So now if I just go to the Python's official documentation, so as you can see, this is the Python's official documentation. So they have written something in meta classes. So what are meta classes actually? So by default, classes are constructed using type, okay? So the type we check, like to check any kind of data type, right? So this is why like it happens. So by default, classes are constructed using type, okay? The class body is executed in a new namespace and the class name is bound locally to the result of type, name, basis and namespaces. So these things I'll be discussing later, okay? So let's just see the example here. So the class creation process can be customized by passing the meta class keyword argument in the class definition line, or by inheriting from an existing class that included such an argument. So in the following example, both my class and my subclass are instances of meta, okay? Now let's see. So as you can see, the meta is the meta class and they have inherited the type class. So type is also a class, okay, in Python. So they have first of all created a meta class by inheriting the type class, okay, and then they have created a class including the meta class as meta, okay? So this they have created, then they have inherited the my class into my subclass. This is a simple example. So by this definition you can say one thing, let's suppose if you're defining some function, just that is a single object, but if you're building a class, so all the class methods and all the things are basically structured by the class itself, and the class itself is structured by a class called type in Python. So in simple words, so type is the meta class in Python. All the Python classes are using type as default meta class. So that is the thing. So in simple words, you can say meta class is a class of a class that defines how a class will behave, okay? So in Python, by default, the type is the meta class of every class that we create, but you can create your custom meta classes also. So the thing is like in Python, you know, like a class defines how the instance of the class will be treated, or maybe how the instance of the class will be working, right? So same way, a meta class is a class of a class. So this meta class defines how the class will act or behave, right? So this is the basically this is the philosophy of meta classes. So now let's jump into the coding part, okay? So let's now see what are the things we are going to cover in this today's video. So first of all, there will be introduction to Python meta classes, okay? And then we'll be talking about how everything in Python is an object. Like we'll be creating some Python classes or maybe like functions. So and we'll see how these things are being an object to Python. And Python allocates some single memory for every object. So that also we're going to see. and then we'll prove something. Proof type is the meta class for every Python class. How we're going to see this? How the like we are saying that type is the meta class of every class that we create, but how? So that thing we will be proving there. And then there is the fourth point: create classes dynamically with type as meta class. So the way we create classes, the class, then the class name. So then we just construct the class. So we will be just creating the class with the type as a meta class dynamically, okay, not with the structured way that we usually follow, okay. And same thing, we will be doing dynamic inheritance with type meta class. So it's kind of fun, you can say, or maybe some creative ways to create classes, or maybe those things. So these things will be you can take care of, okay. So dynamic inheritance with type meta class, okay. So then we'll be explaining some of the magic methods like underscore class underscore. So class method, and these things will be explaining. And finally we'll be creating some custom meta classes, okay. We'll see how to create custom meta class and when to use these things. So that thing we'll be covering in this 7th point. And then in the 8th point we will be using the new and init methods. What are the differences between new and init, and how we can utilize them, both new and init, and the differences and similarities between them, okay. So these things will be covering in this 8th point. And finally the call method and its uses. So it's very useful, okay. So how Python takes this call method. So these things will be taken care of in this 9th point. And finally in 10th point we'll be doing something called Singleton Design with meta class in Python, okay. Singleton Design means like a class can have only one instance. So these things you can see here. Singleton is a creational design pattern which ensures that only one object of its kind exists and provides a single point of access to it for any other code, okay. So this is called Singleton. So these things will be covering how to create Singleton design with meta class in Python, okay. I hope this is pretty clear what and all things we are going to cover in this video, okay. So let's now proceed with the practical part of meta classes, okay. So what and all things we are going to cover, just copy and paste, okay, one by one we'll see here. So first thing first, okay. Okay, so introduction to Python meta class is completed, I guess, okay, as you can see. So in Python, what is a meta class? If I say just revision, a meta class is a class that defines the behavior and structure of other classes, okay. It's quite simple, I guess, often referred to as class factories, okay. In simple terms, a meta class is a class for classes, okay. Just as a class defines the behavior and attributes of its instances of that class, and similarly, a meta class defines the behavior of attributes of classes. Okay, same thing. So some of the key points to understand about meta classes in Python are: everything in Python is an object, right? In Python, classes themselves are objects. They are instances of meta classes. Okay, so a class is the instance of meta classes. And let's suppose you create some instance of classes. That means you just define a class and then you just pass it to the, like this, you can say this example, like this is a class, right? So we are just creating an object. So this is the instance of the class, right? Similarly, a class is an instance of meta class. So this is the meta class, see? So the my class is the instance of my meta. Okay, fine. Okay. Now customizing class creation. So what we can do, meta classes allow you to customize how classes are created. Okay, you can intervene the class creation process, okay, modify attributes and methods, and or you can enforce coding standards for classes. Okay, fine. And the third thing is inheritance chain. In Python, class creation is often controlled by an inheritance chain. When you define a class, it inherits properties and methods from its base class, usually object or other classes, right? So meta classes can affect this inheritance chain. You can do this. So these things are the key points actually, and it's a simple example how we can create meta classes, but we'll see in the next we'll see in the later one. Okay, we'll see later in this tutorial. Okay, so don't get worried about this. Okay, so just let's get started from the second point. Okay, so introduction is done. now we'll see how everything in Python is an object. How? Okay, so just say ki in Python everything is an object, everything is an object. So class, functions and variables, whatever we define, everything is an object in Python, right? So let's just see it, how it is happening. Let's now create a class. Okay, just simple class. So first point is how everything is Python is an object. Okay, so we'll create a simple class named, like, let's suppose ABC. Okay, and this simple whatever, just print, or maybe just pass it better. Okay, now let's create an instance of this ABC is equal to ABC. Okay, so now we have created the class, simple thing, and we have just created an instance of this class, right? So if I just print the class now, if I just print the instance now, so you can see it has created some object, right? And this is some unusual numbers, right? So what are these things? So this thing is actually showing the memory location of the instance ABC. Okay, and this is the hexadecimal number actually. So what it's actually, so it's the unique location ID for each and every object. Okay, so you just create anything and then we'll have this ID in your memory. Okay, so I hope this is clear. And similarly, you can see key everything is an object in Python. Okay, same thing if I just create a function. So we just print okay, so this is the function and this is the memory location, right? So everything in Python seems to be an object, right? So this is the point when we can say this. Let's move to the next point. So proof type is the meta class for every Python class. How we are going to see? Let's see. So as you can say ki we have created the class, right? ABC. So that same example we'll be talking about ABC. So ABC is the instance of ABC, right? Yep. So if I just print ABC, just type and then just print it. So you'll see ki main.abc, that means main is this module, whatever this notebook is, and .abc is a class of this. Okay, so you just say ki let's suppose abc dot underscore class. Anyhow we'll see the class later, but let's see what it does actually. It actually gives you the class names of the instance. Okay, similarly if I just run same thing again class, so here I'll show you one thing. Okay, so what happens here, we just getting type. Why type? So if I just remove this, so we get ABC, right? And ABC is a class, right? And if I again do this underscore class, so you're getting type. That means our ABC is an instance of something, right? And that something is type. Got it? So this small case ABC is the instance of ABC class, right? This one. So you're getting the ABC, and the ABC is an instance of type. That is why you're getting type. So it's funny, I know, but it somehow misleads us to know what type actually is. So let's see what type actually is. So if I just check one thing, type of, let's suppose ABC is an instance, right? So it will give us ABC. This is the ABC class, right? It's an instance of ABC class. So that is why you're getting ABC. It's fine. No magic here. But if I just check ABC, it's the class name, right? It's a class name. So if I just check this type, we are getting type. So same thing if you just refer my video. Anyhow, the video link of this explanation is on the I button. So go check it out. Okay. Otherwise, we can see. So we can say key. Let's suppose we can write it here. So ABC is an instance of a BC class, right? Similarly, ABC class, every actually you can say every class that we create is an instance of a meta class. In Python, it is by default the type. Okay, so you can see, so whatever class we create, okay, that by default is an instance of type. Okay, now same thing, if I just check type of type, it's funny, let's see, again we are getting type. That means type itself is a meta class of type class, right? So the same thing, same diagram, if you just follow, go to the first video of this playlist, you can see this. Okay, so how this is happening, we're not going to go into the much deeper because that is not our task here. So this is why you can say ki type is a meta class for every class that we create in Python, right? Or if I just create a new single other class, or maybe we can import something, right? Import pandas maybe. So now if I just import PD, just importing, check the type of PD. It's a module, right? So just have to create a call a class. Let's suppose PD dot data frame. Maybe data will be I for I in range 10. Okay, we got it, right? So let's suppose it's something df. Okay, and if I just create a type of df, we'll get data frame, right? Df, yeah, it's a data frame, right? Now if I just check the type of this one, data frame, so data frame is a class, right? So now if I just check the type of data frame, right? So isn't it amazing, right? Whatever class we have and whatever class we are creating, that is by default the instance of the type meta class. So this is how meta class is a single entity for every class that we create in Python, right? So what if we could create our own meta class? So that will be much more beneficial for our use cases, sometimes, not every time. So that is the thing. But yeah, so but in this way we can say ki type is the meta class for every class that we create in Python, right? Okay, fine. So let's move to the next point. So next point is create classes dynamically with type as a meta class. Okay, so let me just write it first. So how usually we create the Python classes? This way, right? This is the Python class, and we just simply just write something called underscore init and just we pass something, right? So these things we have been doing since we have been introduced to Python, right? But there might be some other ways to do it, right? How? So let's see it, how we are going to create classes dynamically with type as a meta class. Okay, so let's now see how we can create the classes dynamically with Python. So usually we create Python classes like this, right? So we define some class and we define some init methods or maybe constructors, whatever. So we just create classes in this way, right? And then we create some instance of it and then we access the functionalities or methods, right? So this is the usual way we deal with Python classes, right? But what if I tell you ki there is other ways to create classes dynamically? So let's suppose there is a class, okay, and I'm creating a, let's just to give you the similarity. So this is the class of a, or maybe like or maybe custom class, right? Okay, so this is a custom class and we're just passing it whatever, we don't need anything. So cls equal to custom class, right? And if we just print cls, we'll get to know what is the instance of. So it's an instance of custom class, right? Same way. Okay, if we just comment it out. Okay, so now if we just do one thing, same thing we're going to do. So what is the name of our class? Custom class, right? Let's keep it as a variable. and then we will be passing the type meta class here. Okay, and what is the name of the class? Let's suppose this is the name, right? It's by default name. Okay, so the type meta class takes 3 arguments. One is the class name in strings. Okay, and then we'll get to pass. If we are doing any inheritance, we'll pass this, otherwise we'll keep it blank in parentheses. Okay, I'll show you in the next point when you create some inheritance, and then we'll pass the parameters. If you have any parameters, we can pass it as dictionaries, otherwise just keep it blank. Okay, so now this is a class we have created. Okay, so is it funny, right? Can you create it like, can you create a class like this? No, right? But we have. So if we just create custom class, okay, and let's suppose cls, okay, just print it. And if I just print cls, see, it is a object of custom class. Okay, right? Same thing. Let's do one thing. Let's pass some attributes. Okay, let's suppose name. And what is my name? Okay, we have to give it an strings. Okay, name. My name is Hrisikesh, right? So okay, so now if we just pass it. Okay, so I want to print the name. See, so isn't it amazing, right? So we have just created a class by not using the class keyword, right? So we just have created a class by using only the type meta class, right? So this is how we can create classes also. So, and this is called the dynamic class creation. Okay, so we can pass any number of parameters we choose. Okay, whatever you feel. Let's suppose YouTube channel name. So what is my YouTube channel name? Hrisikesh AI Unleashed Lab, right? Pass it. You can pass this thing. See, let's start. Obviously you have to take care that these things should be syntactically correct. Okay, right, we got it, right? So this is the way we can create classes dynamically in Python with the type meta class, right? Let's move to the next point now. So what is our next point? Dynamic inheritance with type meta class. Dynamic inheritance with type meta class, right? So let's see how we can use this. I hope you are having fun learning these things. So if you just like it, just subscribe to the channel. Okay, thanks. So now let's move to the next point. Dynamic inheritance with type meta class. How we are going to achieve this? So we have created a class called custom class, right? So we have to inherit this class, let's suppose. Okay, so now create a same kind of thing. Okay, just copy it and paste it. So I'll change the name, custom class, let's suppose 01. Okay, and it will be 01, and we'll inherit in this time. So we have to give the class name custom class, right? Done. So we'll call the class name. Okay, and we'll pass some other parameters. Let's suppose age. So I'm 23, and let's suppose whatever job. Okay, so I'm just a data scientist. Okay, so I can say experience 2. Okay, now we just pass, we just call this cls1 maybe. Okay, so we got a type error. Why this? So why this error has come? Let's see. So in Python, if you just have to create a tuple with a single element, right? So we have to pass a trailing comma. Otherwise, the Python wouldn't take it as a tuple, single element tuple. Okay, so this is a syntactical like requirement we have to pass. Okay, just trailing comma we have to pass. Okay, so after the class we have to pass a trailing comma. Now let's run it. Now there is no error, right? It has occurred. Now let's see the inheritance is working or not. cls 01 dot. See, we have everything: name, job, experience, age, everything, right? And the magical thing is key, we have not created any class with the class keyword. Everything we have done with the type meta class itself. Till so far, whatever class we have defined, whatever class we have created, everything we have created with the type meta class, right? So this is a new way we can create classes. Okay, and this is more often easy maybe. Okay, so somehow we can create, just pass a name, pass the attributes, and if you want to inherit something, just pass the inheritance, like pass the like parent class name, parent class object actually. Okay, so same thing we have done. And if I just call this name, we don't have anything called name here, right? Because we have inherited the previous class. If you just pass the name, we got this from here, right? We got the YouTube channel, right? Okay, so we have to take care of the naming conventions. Right, we got the attributes of the previous like parent classes, right? So this is somehow tricky, right? Handy also. So we have created classes dynamically with type, we have created inheritance with type. So these two things are very much useful and handy when you use Python for your projects or maybe some frameworks or those things. Okay, so let's now move to the next point. I hope till so far you have understood the points, and if you have not, if you have any query, just let me know in the comments. So now we'll explain the sixth point, what is the class method here. Okay, I'll explain the class method here. So let's now use this. Okay, so one thing to notice, the class is not a method actually. Okay, it's just a attribute. It's just a special attribute that that helps us to know the class of an object. Okay, so let's suppose we have imported pandas, right? Df, right? We have df. Now what is that df dot class? So it's a class of data frame. Similarly, same thing I think I have checked, right? We know same thing, right? So by this we can say ki whatever the type is printing, the same thing we can print with the underscore class methods, class attribute, right? So this class attribute helps us to know what is the class of the instance, right? So same thing we can see with type, right? So this is handy also. So this class method actually helps you to know the parent classes in the runtime. Okay, so it helps you to know this like what are the class belongs to, and just for debugging or maybe to create dynamic ways, so we can inherit those things. So these things are pretty much handy for it. Similarly, we have something called name. What is the name? So it's not that much important, but I have kept it in this video. So let's suppose the ABC is the object, right? So if I just create a name, or maybe class, so class dot underscore name. So the name we are getting from the here itself. So this is a name actually. This is a name by default. And how we are getting a name? So you just notice one thing, we have passed one thing, same name, right? If you just pass the other things, let's suppose wonder, okay, just pass this now. So if I want to check the type of CLS, so I have to show you one thing, that previously if I just call this CLS dot class dot name, so we are getting custom class, same thing, right? But if I just write wonder, So we get wonder. We're not getting this class name, right? So by default, if you just use the class keyword to create your classes, your class name is a name by default. And if you just create dynamic classes, so you have to pass the name here. Okay. So now one thing I can show you right now, I can go to the type, the definition of type. Okay, let's go there. So you can see there is something, the base and dict and all those things. There is not, it's not important. You can see there is underscore name. Okay, and there are the new methods, there are call methods, there are everything, right? So not everything is our task to know. Okay, so these are attributes in the type definition, right? So we'll not go into much depth here because that is not our task here. Okay, so this is how we can get to know the class names here. I just remove it. Okay, so now you got to know what is the name and what is the class doing here. Okay, so this thing we can create, we can call these things, and we can know what are the class names and what are the class objects, right? So that we can help it to get to know about the details of the class, right, or of the instances, right? So this is handy, right? Again, not a big deal. Okay, so then now finally we are going to create custom meta classes. Now this is the point we all were waiting for. So let's jump into this custom meta class creation, right? So let's jump into this. So let's now create a meta class. Okay, so same thing, just create a class. Okay, let's suppose meta class. Okay, and we have to inherit the type meta class by default. Okay, because it's a meta class. Okay, so now we can just pass it. Okay, initially just pass it. Okay, now create another class with simple test maybe. Okay, just pass it, and now just create a class with the meta class, custom meta class. Okay, custom class with meta. Okay, let's now pass the meta class keyword, class equal to meta class. Fine. Okay, so let's run this one by one. Now we are going to print it. Okay, now just first of all print the simple class, that is test, right? Now we are going to print the class of this one, right? Custom class. Okay, let's print this now. So as you can see, this is the class of test, and this is the custom class with meta. Okay, so now let's see the type of these things. Just type, right? Type. So to print this, first of all, so as you can see, the first class that we have created with the class keyword, like same thing, like this is a similar way we create the classes. So this is by default taking the type as meta class, but this particular one, this one custom meta class, so this is taking the meta class as the meta class, as we have defined the meta class in the definition of the class, right? So this is how we can create classes. Now more things we can do here. What and all things we can do? So let's just explore. So I'll be doing here itself. Let's just copy this first of all, paste it. Okay, experiments I can say. Wait. Okay, fine. Okay, so let's now do some experiments here. Okay, so you just create a class with name, basis, and dictionary, right? Now let's do some experiments with the meta classes. Okay, so this is a meta class I have created. So this is a meta class, and we have inherited the type by default, and the CLS method is associated with it because by default it is going to associate with the class that we are going to create it with, right? And the name we are passing same thing, right? Same name. We just, this is the name, and the class if you're inheriting something, or maybe and is the attributes, right? This is the base, and this is the name. We call it name, base, and attributes, right? So these all things we have created here. So this is the pointer, and we have name, bases, and attributes. Okay, so just to make you clear, I'm writing these things. So name is the class name. Basis means the base class, or maybe you can say parent class. Okay, and one more thing I can say ki attributes, right? Okay, and attributes are what are the attributes? Attributes are the attributes, or you can say parameters to the class. Okay, so that is it, and let's just do something. So we have created a new attribute. Okay, you can create whatever you want. Okay, CLS dot class number. This is a class number 3 we're doing here, right? So these things we can create here itself, right? Now let's create an instance of the class. So this is the instance of the class. Okay, now we have used the myMeta as a meta class, similarly to the previous one, right? So we have used the meta class keyword, and we just passed the myMeta class here, right? And we just created a value, just simple thing, and that value we are going to print in this print value function. Simple thing, right? Simple. So now if I just create an instance of the class, so like my CLS, maybe my class. Okay, now what are all things we know? We need value, right? And it will be, let's suppose maybe 23. Okay, now if I just want to keep my CLS dot print value, right? So it will print the 23, right? Nothing magical. But what if we just want to access these things? So we have not used any kind of inheritance, right? We have just used the meta class. So if we just want to check what is the meta class here, so just write type of my class, right? And we'll see the type of meta class is my meta, right? So this is the way we can see. Otherwise we can say ki my CLS dot underscore class dot underscore class, right? We'll get my meta. It's a my meta class, right? Same thing. So what are all things we are going to do now? So let's put my CLS, and if you just see, we have given some kind of attributes, right? New attributes and class number. Let's see, new attributes is there, right? Yeah, we got it, 42. And if I just check the class name number, you got it as 3, right? You just pass anything like CLS dot magic equal to true. Yeah, it's magic. So let's just use this as magic. Yep, right? So we got this my meta class as the meta class of this my class, right? Pretty much handy, pretty much useful, and fun creating these things, and maybe learning something new, right? In some other ways, like it is not an usual way we create these things, but yeah, it's some unusual way, but it's fun, it's creative, right? So we have created classes, we have created custom classes, we have created custom meta classes, right? And we have seen how to access the variables of custom class. Whatever you have just want to do, you can just do one thing, like you can create your like let's suppose you are connecting to some databases or maybe somehow, so you can pass these things to here, and it's pretty much handy for you, so you don't need to inherit every time. So it's just a meta class. So this is how it can be handy. Yep, right? So let's now move to the next point, right? let's get jump into the next point. So there comes something interesting. This is use of underscore new method, underscore new and init. So these are the attributes or special attributes, you can say, right? So these things we are going to discuss here. Okay, so let's now discuss about the new and init methods or attributes. Okay, let's say. So okay, so let's now discuss about the new and init attributes. Okay, so what are all these things? In Python, both init and new are special methods used during the creation of initializing objects, right? But they serve different purposes. So, okay, but what are these things? So new method, what it's actually. So the new method is responsible for creating a new instance of a class before init is called. Okay, I'll explain it more in when we'll go to the code. So initially, usually we define the classes using the init keyword, right? Init attribute or maybe magic methods, special methods, right? So but before init, by default the new is called. Okay, and it's called by the meta class itself, right? It is defined there. So the new and init are both important for to initialize an object of a class, right? But new comes first. Okay, when you are dealing with the classes, you are creating an instance of the class. Okay, so like if I just show you, so I have created a instance of my class, right? So my CLS, this one is the instance of my class, right? So whenever you are creating an instance of the class, okay, you can create innumerous number of instances, right? So whenever you're creating an instance, so it is by default, first of all, it's calling the new first and then the init. Okay, so that is what happening here. So it is a static method that takes the class as its first argument, CLS, right, and returns a new instance of the class. Okay, fine. So you can override new to customize the creation of the instance. Okay, you can just customize. Okay, we'll be creating this one, and it's often used when dealing with immutable objects. Okay, or to control object creation in meta classes. So this last one I'll show you when once like we'll finish it. So the last point we have this one will be creating singleton. So if we want to control object creation in meta classes, so these things will be singleton classes, will be defining this thing. So this is also a point of new, and it is called before init, and it is used to set up the object state. Okay, fine, good to go. So now just create a class with the new method, right? So this new, we can obviously define it. Class will be defining here. Okay, so this is the class object we are getting here, right? And so now we're going to create an instance. We are just initializing the super class. That means let's suppose you are not inheriting something, or just if you are inheriting something, or maybe you have a very complex hierarchical inheritance. Okay, multiple inheritance going on. So these things might be handy for you. So it doesn't affect your code. Okay, but you can use this is a good practice. Okay, to use super. So just super of my class. So it's basically it is referring to the base class. Okay, and we're just initializing the base class's new method. Okay, same thing. Okay, now we're just initializing the values here. Whatever values we are getting in args or KWS, that you can do here, no issues. The simple thing one. Okay, simple thing. So then we return the instance. Okay, now we're returning the value here, the new and init methods, right? So there's a difference here, you will see once we get to know it. Okay, so now just creating this. So the value we got here for 42. So now let's check what is happening here. So in this example, the new methods creates an instance and sets its value attribute based on the argument passed to the constructor, right? So this is what happened here, right? You got my point. And if you just print it, you'll see new is called. Okay, and if you just print this, init is called, just run this. So first of all, new is called, then init is called, then 42 here, right? And also wanting to notice ki new actually decides whether to call the init or not. Okay, fine. Yep. So this is the simple example of new, and let's see what is a init method. Okay, So the init method is responsible for initializing the created instance after it has been created by new, right? So the instance is created by new, and then the init method is responsible for initializing the created instance, right? So it is initializing the instance, okay? So it's an instance method and takes the created instance as its first argument, okay? So this is the instance method, okay, and this is initializing the instance, and it is taking the instance name as the keyword with self, right? And init is where you typically perform attribute assignments and other instance specific initializations, right? And it is automatically called after new when you create an object, okay? But also this, I told you ki this might be decided whether to call this init or not. Sometimes the init is not called after the new ones, okay? Okay, now let's just have an example. This is a simple thing. We have seen this init every time we create a class, right? So this init is defined by this, right? Okay, fine. So now in this example, the init method initializes the value attribute to the object based on the argument passed to the constructor, right? In summary, so what is the summary of these things? So new is responsible for creating the instance and can be used to customize instance creation, right? So we can customize the new method, okay, to customize the instance creation, while init is responsible for initializing the instance after it has been created by new, right? So we'll primarily use init for typical object initialization, and while new is used for more advanced scenarios such as working with immutable objects or customizing class creation, right? So these things are pretty much handy whether you talk about the meta class and this new and init methods, okay? So this is the difference between new and init. So let's now discuss about the next thing. We have the call method and its uses, right? So let's just use it. So let's now talk about the call method, okay? So what is a call method? So in Python, the call method is a special method that you can define in a class, okay? So when we define the call in a class, you make instances of the class callable. I'll show you later. So just like functions, we can call the objects of the class, okay? We can call the instances of the class. So when you call an instance of a class by using parentheses, Python will invoke the call special method, okay, the call method of that instance, okay? So I'll show you. Let's take an example. So let's create a class. Let's suppose call test maybe, okay? So just we'll do one thing. We'll add an init. So init, and we can pass let's suppose two numbers, okay, num1 comma num2, okay? These two things will show, okay? Now we can add self dot num1 equal to num1 and self dot num2 equal to num2, right? So this is the usual way we create the classes. Same thing. Now here we can define the call method, just same as we define the init, same thing, right? So args and kwargs you can pass for your ease, okay? Otherwise you can just keep it blank if you don't need them. Just whatever if you just don't need them. So now we can introduce something called maybe whatever num3, right? Okay, so now what we'll do here, we'll take, it returns self dot num1 plus self dot num2, okay, and we'll take this self dot num3 also. Sorry, it's not self, just num3. Done. Yep. So this is the simple class we have created till now, right? So no fancy logic, okay? So now what we can do, just let's create an instance of the class, okay? So instance equal to call test, okay? And we need num1 and num2. So num1 will pass as, let's suppose 3, and num2 will pass as 4. Okay, so now till this part it's fine, right? We know these things. Now what if we want to call this? So how to call this? Just call the instance, and we got the num3, right, by default. So num3 we can pass as, let's suppose, 10, right, and we'll get 17, right? So this is the simple logic actually. So if you want to make the instance callable, you just pass the call special method in the class. Okay, while defining the class you just mention the call special method, and then you can just create the instance as a callable one. Okay, so this is the way we can do these things, so that like it's better to make these things very useful. Okay, so this is all about the call, nothing fancy, but yeah, it's so useful actually. Okay, so that's it. So let's jump into the next topic, which is our last one, that is Singleton Design with Metaclass. So before that, what is Singleton? I'll show you. I think I have shown you, but again I'll show you. So it shows you, see, Singleton is a creational design pattern which ensures that only one object of its kind exists and provides a single point of access to it for any other code. Okay, so that is the thing. So let's now code it out. So this is our last topic. So what is this Singleton? So I told you, right? But one thing, like let's suppose you are creating a class, right? So you can create any number of instances, right? But what if we wanna like restrict the user to create only one instance? So that is called Singleton Design. Okay, so let's create it. So first of all, we'll see how we should know how many number of instances are being created. So you can see this, but let's create a class. Let's create a meta class. Okay, we're not implementing here any kind of Singleton design, so we'll call it not a Singleton. Okay, so we can create any number of instances, but we'll see how many instances we are creating, right? So that's the thing. Let's check it out. So we'll do one thing, we'll introduce a variable called instances, and we'll store the numbers here, numbers and like objects and the class names. Okay, so these things we are storing here, and let's just create the call method. Okay, we need to change it to CLS. Okay, fine. Yep. So what we'll do actually, we'll not return it first. So what we'll do actually, so we'll just store it. Okay, cls dot instances equal to, and we'll store cls here equal to okay. So we'll use this, and then we'll do one thing, we'll just print it. We'll see how many instances are being created, so we'll see it. And I'll print it once. Okay, we'll just return simply cls dot instances. Okay, so we'll create two classes here. Okay, one is one with this not singleton, okay, as the meta class, and one more not singleton. Okay, now let's create two objects here. Okay, now let's run this. So as you can see, like while initializing the first one, we just had one instance because we have created only one instance of it. So we had this one only one, and this is the like key and value. So in key we are just storing the name, and in value we are storing the object itself, right? So this is the thing. And second one, when we are creating the second instance, we're getting the length of 2. So we're storing 2 instances here, right? So this is how we can like introduce as number of instances as we want. So by default you can create any number of instances, but if you want to specify the user like they should not use more than one instances, so how to use that? So that is called Singleton Design. So we can use this by creating a meta class. So how to do that? So let's do this. So by default you are allowed to create any number of instances, but there comes the usability of meta classes, right? That you are not allowing the user to create more than one instances. So these things you can customize all these things, right, in meta classes. So we have till now we have just one instances for each class. So I'm showing you with a not singleton design. So there is total 2 instances, right, of 2 different classes. So one for each. Now if I just create 2 more, a 1 equal to 1, a2 equal to b1 equal to 2. So if it's not a singleton design, it will give us all 4 of them, right, as you can see. So before implementing the singleton design, we have to see how we can create any number of instances, right, of a single class. So you can create any number of classes, any number of instances, right? There is no limitation. But what if we want to restrict the user to create only one instance for each class? I'm not talking about meta class. So for each class the user is supposed to create only one instance, no matter how many instances they are creating, but we are only limiting the user to create only one instance. Okay, so that thing can achieve with singleton design. So let's do one thing. Implement singleton meta class to avoid creating more than one instance of a class. Okay, so now let's create this class singleton meta class. Okay, let's inherit type. Okay, and by default now we are going to do this same thing, instances. Okay, now define the call. So one thing we'll introduce here, just a condition: if CLS not in CLS dot instances. Okay, if it's not there, then it should create it CLS dot instances CLS equal to. Okay, I hope this is understandable. Okay, now let's simply return it. And whenever we want to check what is the like length or maybe we just print the CLS itself. Okay. So now if I create two classes, one meta class would be and one more thing to notice, if you create two one classes with the different meta classes, you will get two objects, right? So this is not some magical, but yeah, it's useful. So let's give it some other name, maybe. So now as you can see, so we have created two different classes and two different instances, right? So as you can see, let's create any number of instances. So if we check the length of it, you just get every time two instances, right? There is no more than that. We can create any number of instances. Let's suppose so if I just run them, as you can see there is a lot of number of instances, right? But if I just print them, so you get only two number of instances, right? Because we have two classes only. So that is how we are like limiting the number of instances creation to only one. So that is called the singleton design. Okay, so that's it for this video. I hope you have understood the tutorial, and if you have any kind of comments, any kind of queries, just let me know in the comments, or my LinkedIn profile is in the description, so do follow me and hit a like to this video if you like this, and subscribe to the channel and press the bell icon so that you never miss the latest videos. Thank you.